how did you use multiples to find out how many tiles will have both a flower and a border? Who would like to explain it in their words? Yes.
When you multiply all the way from 6 times 1 all the way to 6 times 7.
Okay.
It equals 42.
Okay, can we do the multiples? What were they? 6?
6. Wait, like 1, 2.
Yeah.
Yeah. 1. I got 6 times 1. 6 times 2.
What is 6 times 2?
12.
Okay, give me the next one.
6 times 3, 18.
Okay.
6 times 4 equals 24.
Okay.
6 times 5 equals 30.
Okay.
6 times 6 equals 36. And 6 times 7 equals 42.
Okay. Did you do the same thing with 7? What are the multiples of 7, class?
7.
Everybody together, please. The next one?
14.
Okay.
21. 28. 35. 42.
Okay. Do they have a common multiple? Do 6 and 7 share a common multiple? What is the common multiple they share, Angeli? 42. This is so the only time when we're doing this pattern, the only time that we're going to get a flower and a border on the same tile is which tile? The 42nd tile is the only time we're going to get both a flower and a border. So what was my question? Go back to the question. Everybody look at the question up here. So we're looking for the number of tiles with a flower and a border. That's the question I want to know. How many tiles have a flower and a border in the on the tile? What do you think, Jalen?
1.
Just one tile, right? Which tile is it going to be? The 42nd tile. So only one where they're going to meet. Okay? And this goes into this skill we'll be using on today's lesson. What lesson are we on today?
6.
Martin has 2 cakes that are the same size. One cake is cut into 1/2 size pieces. The other cake is cut into 1/3 size pieces. He wants to cut the cake so that they have the same size piece. How can he cut each cake? So he already has one here that's cut into half and one that's cut into thirds. Do you see that? Now from this, he wants to cut the cake so that they have the same size pieces. Can he do that with these 2 cakes? Even though they're in halves and thirds? Let's see. A new vocabulary word for today is common denominator. We just did a common multiple. We've done common factors before. The common denominator is the same idea, only in a fraction. If this is my fraction, which one's the denominator? The 2, the bottom, is the denominator. What's the top called? Numerator. Okay. So we're going to be learning how to find common denominators because we have a reason. A common denominator is a common multiple of the denominator. Just like we did on the board, a common multiple, it's just that we're doing it for the denominator. Fractions with common denominators represent wholes cut into the same number of pieces. So, are these cakes currently cut into the same number of pieces?
No.
No, but we can cut them into the same number of pieces by changing the denominator and then making the cuts. And that's what we're going to do right now. Our right side elbow partner is going to do step 1. It says model the cake cut into 1/2 size pieces by folding one sheet of paper. Hold on, let me finish. One sheet of paper in half. So right side, go ahead and take your paper and fold it. Look at the way they did on their cake though. You see how they folded it in half this way? So fold your half, use the horizontal fold. So it should look like this. Draw a line on the fold. So I'm going to open my paper. I wrote on myself. And I'm going to draw a line down the center. It's not going to be ooh, that's really not perfect. And I'm going to draw a line down the center. Not perfect, but it doesn't matter. We're just trying to get the visual. Step 2. Model the cake cut into 1/3 size pieces by folding the other sheet, don't fold yet, but by folding the other sheet into thirds And then what are we going to do on the folds? Draw a line. So this is how you fold a paper into thirds. We're doing it this way. You kind of fold one side in and then the other side and kind of mess with it till they're about equal. Do they have to be perfectly equal? No. This is not art class. But we're just trying to get a visual. So it should be, the pieces should be about this size, see? If I open it. Step 3. Fold each sheet of paper so that both sheets have the same number of parts. Draw lines on the folds. I want you to together decide how you can take this and fold them so they have the same amount of parts. Work together with your partner. This is a partner thing. We have our cake that's divided into thirds like this. And then we have our half cake that's divided like this. And so what I've seen some of you were doing was saying, well, if we take this paper and fold it in half just like the other one, because we can do that because there's already a line through the middle there, I can make a line through the middle here. And so now I have that. We're not drawing yet. Could I do that? Could I apply the same method to this paper?
Yes.
How can I apply the same method to this paper, Benny? Where I was dividing it into thirds. So then I'm going to take this one and I'm going to divide it into thirds, just like I did before with the other one. Oops, sort of. And then I'm going to draw my lines. My squiggly, I gave up on trying to make them perfectly straight. Now, are my two cakes cut the same now?
Yes.
How many pieces are each cut into?
6.
6 pieces. Are they the same size?
Yes.
These pieces are cut the same size. So if I was serving 12 students, they would, with these 2 cakes, they would all get the same size piece of cake, even though we started with our cake being cut this way in half and this way in thirds. Okay, so we're going to answer this right here where it says, how many equal parts does each sheet of paper have? So how many equal parts did we have? 6 equal parts. Draw a picture of your sheets of paper to show how many pieces each paper could have. So go ahead and right now and draw your 2 sheets of paper like this and show how you split that up. Into 6. The next question says then, so each cake could be cut into how many pieces? We've already answered that, but how many pieces? 6 equal pieces. Here's an example of how to use our common multiples to find common denominators. It says, write 4/5 and 1/2 as a pair of fractions with common denominators. Do they share a common denominator right now? No, 5ths and halves are not the same size. If I took 2 pieces, or 2 pizzas, I want to just show you. So eyes are up here for a reminder. If I was going to split this one right here into halves, that would be the size of each piece of pizza. If I was going to split it into 5ths, maybe, ooh, not bad. Okay, so that would be 5ths, the size of the pieces, I can't even speak. That would be the size of a fifth, each one of these. Considerably smaller than a half, isn't it? So finding a common denominator, we have to decide how to get these pizzas into the same size pieces. Okay, so the first thing we're going to do is find the multiples of each of the denominators. The first one is 5. So a multiple of 5 is 5. No, not factors. 5. Multiples. 5, 10, 15,
20, 25, 30.
and they didn't give us any more lines, so I'm going to stop there. Now I'm going to do the common multiples of 2. 2 first. 2.
4, 6, 8, 10, 12.
Do you see a common multiple? Raise a quiet hand if you can tell me a common multiple of 5 and 2. And what common multiple is that? 10. So they have a common multiple that is 10. Okay? Now we're going to use equivalent fractions that we've learned about to find a fraction that has the same denominator as 10. We've done equivalent fractions, so don't get all freaked out and scared. So, if I'm going to take 4/5 and I want a fraction that has tenths as the bottom, how would I get from 5 to 10, from fifths to tenths? I need eyes up here. Thank you. How would I get from 5 to 10? What would I multiply by, class? 2. So in equivalent fractions, if I multiply the denominator by 2, I have to multiply the numerator by
2.
what is 4 times 2?
8.
So this fraction is also equal to this fraction. Remember equivalent fractions. Okay? Let's look at the bottom one. I want to change 1/2 into a fraction that has a 10 as a denominator. What do I need to multiply 2 by to get this 10? Multiply it by 5. If I do it with the denominator, I have to do it with the numerator. So I'm going to multiply 1 times 5. Why 8? Someone said 8. Okay, 1 times 5 is 5. So 1/2, an equivalent fraction of 1/2 is 5/10. So now I'm looking at these two fractions. I can see that this one equals 8/10 and this one equals 5/10. I can actually compare them now because they're the same size pieces, right? Same size pieces of pizza. So you can write 4/5 and 1/2 as 8/10 and 5/10. Now they have a common denominator. Are 4/5 and 1/2 equivalent? I want you to think about that for a second. Okay, so you went ahead and just tried to make an equivalent fraction. You said if I was going to go from 1/2 to 4/5, I know that I'd have to do 1 times 4 to get the 4 here, which means I would have to do 2 times 4 down here, which does not equal 5. It equals 8. So that's a great way to check if they're equivalent fractions. Because you can get from 1 to 4 just by multiplying by 4. Then you can double check by doing the denominator by that same number, and you see that that does not equal 5. So they are not equivalent fractions. You can also look at what we did up here, where we gave them a common denominator. So the size of the pieces are the same size. How many do I have here? How many do I have here?
8.
Why do I only have 3 people awake? How many do I have here?
8.
How many do I have here?
5.
5. So are those equal numbers? No. If these were pieces of brownie, which would you prefer to have?
8.
8. Because you recognize that that's more than 5 pieces. All right. Describe another way you could tell whether 4/5 and 1/2 are equivalent. So we just actually did 2 ways. We did this way, and we did by looking at these with a common denominator. What's another way? I actually did another way, and you could even figure it out and explain. What would be another way? Go ahead and discuss with your partner and write down an explanation. So you can half this one, but you can't half this one? Is that what you're saying? Okay. So if you're looking at that this is a half, and so this one's not a half, so that helps me see that they're not equivalent. All right, Horace?
Divide by 4, it equals nothing.
Like this, right? So you can do the backwards, what we did simplest form, trying to do simplest form. But if you divide this by 4, it doesn't equal a whole number. You can't do 5 divided by 4 and get an equal number. So that doesn't work. Okay? Someone try a different method? Did anybody try that method? Right? You can draw a picture and show that they're not equal. All right. That would be another way. And you could describe it by drawing a model. Find a common denominator for 1/3 and 1/12 by dividing each whole into the same number of equal parts. Use the models to help. So if I look at the models over here, I can see that these already are divided into thirds across. Is this one divided into thirds across? Look at, I'll use my fancy paper. Do you see this line goes across? And this line goes across? So they're divided into thirds across already. How can I make this one look like that one? Can I? How would I do that, Haley? Yeah, fold it 3 times, and how many sections would that be? 1, 2, 3 fourths, right? So I see that there's a half line right here. I'm going to go ahead and draw my half line. And then I see each section is also divided. Does that look similar to that one? Mm-hmm. So I didn't change this one, did I? Eyes are up here. Did I change this model at all? Did I change this one?
Yes.
Yes. How many parts do I have now? No, total. Count them real quick, quietly. Count them real quick, quietly. How many parts do I have total? 12. So I want to change this denominator to 12. How am I going to get from the 3 to the 12? Raise a quiet hand if you can tell me.
Multiply it by 4.
Times 4 equals 12. So if I multiply the denominator by 4, what do I have to do with the numerator? Multiply it by 4, which is?
4.
So this is now called 4/12, and this is still called 1/12. Did I have to change? The denominator on both of them to have a common denominator? No, I did not. Sometimes one denominator works, and you work towards that one, and you only have to change one fraction. All right. So what was the common denominator here? Write the pair of fractions as a pair of fractions with common denominators. Now, let's look first at the denominators. What are my denominators, everybody?
2 and 4.
2 and 4. Do those have anything in common? Can we see a connection? Raise a quiet hand if you see a connection between those two numbers. Lydia, what do you see? 2 times 2 equals 4. So I'm going to put my 1/4 over here because I'm not going to have to change that, and this is why. I'm going to change my 1/2. Lydia says if I do times 2, I get 4. So then I do the numerator times 2, and I get 2. So now I've changed 1/2 to 2/4, and my 1/4 is going to stay 1/4. Do they have common denominators?
Yes.
What is the common denominator? 4. Okay. Let's look at number 4. When I look at those two numbers, do I say, ooh, I see something common about them?
No.
No. You have a 3 and a 4. So how am I going to find the common denominator? Raise a quiet hand if you can explain to the class how I'm going to find the common denominator. Ronnie, what do you think?
You keep multiplying until they get a common number.
Very good. I like keep multiplying each one. You're basically finding multiples until you find a common one. So 3, 6, help me out.
9.
9.
12.
I'm going to stop there. 4,
4,
8.
12.
Oh, see, now you see why I stopped there. I got a common multiple. What is my common multiple? 12. Now my pen's kind of fat to make this all happen on this little square, but I'm going to do 3 times what number equals 12? 4. So I have to do the numerator, times 4, which is 4. So this is one of my fractions, 4/12. That's this fraction. And now I have to change 1/4 to be 12ths. What am I going to multiply the 4 times? 3. And what am I going to multiply the 1 times? So this is my fraction that goes with this fraction. These two are equivalent. These two are equivalent. So if I'm looking at 1/3 and 1/4, I have 4/12 and 3/12. Let me ask you, just really get crazy here. Which one of these is a greater number, 4/12 or 3/12? Nicholas?
3/12.
Is greater? Think about it. If I cut a pan of brownies into 12ths, would 4 of them be more or 3 of them be more? Right, so 4/12 is greater, which means that which one of these fractions was greater? Look at it first and raise your hand. If 4/12 is greater than 3/12, which one of those happens to be greater? Benny? The 1/3. Because remember, the 4/12 equivalent fraction of 1/3. But that's not today's lesson. Oh yeah, it is right here. It says whether, oh no, it says whether they're equal or not equal. See? Right here. Are they equal or not equal? Okay. All right, go ahead and try number, what? Do you have a question?
You actually use your method that you're using to find a common factor.
That's how you do it. The other option is, do you notice what 3 times 4 equals?
Yes.
What?
12.